Yes.
NH. Phải thủy, mát thủy.
Good, so more or less. All right, so last week, then, last Friday we were not here, and I talked about neural networks. So it is not part of the exam, it was just essentially because I thought, okay, it looks like they're interested, then I gave a little treatment. And then sort of to see that this is what it is, what are its restrictions. And well, let's say I try to do the estimation of a CAP-M model, and then the CAP-M beta, which is a derivative, was actually very ugly, which meant essentially that, well, that's actually a long-standing problem of neural networks, so they're not explainable. Explainable in the sense that CAP-M beta has a meaning, you can explain and say, okay, what is that? And the CAP-M beta that you could get using the neural networks somehow is not really in line with our intuition. Which is the problem with the explainability of neural networks. Okay? So which essentially means that you cannot use them to estimate parameters, the coefficients, but it is good when it comes to fitting an output to a set of inputs. Right? So that's sort of in a nutshell what it is, and then some implementation which you'll find them online. You can take a look if you have questions that, or the others, because the others and because I started that, then I didn't actually do the multivariate garbage, which I don't want to do, actually. I just will tell you how to do that in the stat. I mean, we can't do that in Python, so just leave it out. And then I also, yesterday actually, I tried very much to find some data which is Vietnamese, and I could do some analysis with it. It didn't work somehow. I went to this website, GSO, General Statistics Office of the sort of the government, and then the data were not easy. And so they were a little bit dirty, so I had to do a lot of data work so that I got clean and I could do some analysis. And for example, I looked at the industrial production, so sort of not in the NGARCH, but rather in general. And I figured out that the data exists from 2008 till June 2025. So I could find it. But the problem was that data from 2008 till 2012 had a reference, so sort of they were, the reference point was the average year of 2005, which I didn't have the data for. And then from 2013 till 2017, then the data were normalized with respect to the average of 2010. And then afterwards, the data were normalized with respect to 2015. It was really very ugly. I couldn't actually have something that would have.
Cái mic đâu? Cái mic. Rồi, quên cái mic rồi. Cái mic không có mic là không có ghi được hết.
Is here?
شده بگید
No. I don't see the microphone. Okay, so I will talk and go on. I can't do anything else. So it was really hard, essentially, to get some data that I would like to analyze. So what I will actually now tell you is, oh hi, good morning. Microphone. This side, and this I also. I give it to him. It's not for me. Now I change this. Thank you very much. I'm good. Thanks. Actually, I wanted to tell you that this is probably, what was her name of Fogo? What is her name?
Thuy. Thuy.
Yes, she's the wife of Dr. Ha. That is the same name? No.
No.
Thuy.
Thuy.
Thuy. Thank you very much. Thuy. All right. So, well, so as a result, I decided that I will not go through it, and then given that you know how to do a stat, I will just tell you how it is done in the stat, or sort of what it is. The syntax, and give you a little bit of an idea of what you can do with this, right? Sort of, an idea just. And then the work I leave for you. Then we use a project for some applications here. Where the function is called mgarch. And then let's say we want to do DCC. So the dynamic conditional correlation basically. And you say mgarch DCC. Right? If you have constant conditional correlation, then you say mgarch CCC. Right? That's as simple as that. And then comes the basic variables. Right? So when we have a number of options, we should see how they work. Right? And then we just show you the equations that this estimates, so the DCC. So that's the same model as we had discussed the other day. Right? So remember we had a Q, and I told you to invert it, and so on and so forth. So that's the same thing as we had it before. And then this QT had the dynamic. First of all, this dot that we have here is a dot product. So that's a Hadamard, or element wise in productive in matrices. So that's something that you keep in mind. And then we have A and B. So that's the model that Engel 2002 indeed proposed. But let's say you have, well, remember that's iota times iota, so that will be a matrix of ones. All right, so a matrix of, so that will be a vector of ones times its inverse, so that you get essentially a matrix of all of its elements are one. But because these coefficients are sort of matrices, then it becomes hard to estimate because you will have many parameters. Right? So Engel actually proposed to simplify this. Right? So that's sort of what we have. And then look at this QT. Right? So the QT that we have here on the slides is there is an S, and then there are all of those guys. All right? And then, well, Engel by itself actually said, okay, so if you have that, this Q is the Q star that we had. All right. So instead of a matrix of one, then he said that, okay, let's simplify this. And then instead of these A and B matrices, then let's have identity matrix scaled by lambda 1 and lambda 2. So they became two parameters. And regardless of what is the dimension, then indeed you will have lambda 1 and lambda 2. So not A and B and S, but rather lambda 1, lambda 2, and lambda 1. I mean, that's sort of iota prime minus A minus B. Right? So that is what we have. So if you compare the two, then you will see that this is indeed, well, a reduction of the dimension. Right? So instead of A and B, which is 3 by 3, 3 by 3, and S also 3 by 3, right? So which is 27 parameters. then here we have only two parameters, lambda 1 and lambda 2. So far so good. And there is some R, well that's some initialization. One generally takes it to be the average of this, and then somehow the rest is numerics. Okay? But once you estimate indeed a model with MBCC, then you get all of the parameters of the conditional electroscholasticity in the model. All right. So whatever it is, say if it is a large one, then you get all of the parameters. And let me maybe show you an exercise of this. For example, let's say that is the exercise that you see in the STADA web page. Right. So what it does is that so here we have the stock returns of 3 car manufacturers, Toyota, Nissan, Honda, from this time period. All right. And they are in these variables. The conditional heteroscedasticity model, first order Vetter autoregression, sort of you have for the mean. All right. So here, what we have, let me just write the equations on the board. All right. Let's say we have some y t. All right. It has a mean, let's call it vector y. So that's a 3 by 1 vector. This is also a 3 by 1 vector. Plus some capital phi1, yt minus 1, so that's a VAR over the 1. And now comes the third term, alright? So let's go to UT, where UT is an M-Garch dynamic conditional correlation model of orders 1 and 1. There are just 2 lag. 1 lag for the residuals and 1 lag for the past heteroscedasticity. Alright, so that's sort of what we have. Indeed, we can include, well, the mean equation is not fixed, but that's AR. So it becomes a VAR. VAR, vector autoregression of order 1. Clear? And so let's say you want to estimate this, then that will be the specification. Then we will say MGARCH DCC, so these are the 3 variables, right? Well, here they opted for no constant, setting this to 0, so you can leave it to be whatever. But then, so you have to specify the equation. So if you don't put these equal, all right, equality, then you will be essentially estimating no mean equation. So ARs will be 1, but here we have AR. So lag of Toyota, lag of Nissan, lag of Honda, and no constant. So mu is 0. Right. And now comes the arch and gauge. Alright. So here we have the arch. So these are 1 lags of the square of the residuals. Well, in matrix format, and this is gauge 1, so there is 1 lag of the heteroscedasticity. So you have to specify these options. And then you get basically some results. Let's go on. I mean, first you get the coefficients on the Toyota equation. All right, so we have Toyota, Nissan, and Honda. All right. So Toyota, so that is the AR coefficients, right, that we have. So the Toyota equation has a negative coefficient on its own lag. All right. Toyota equation has a positive value, but they are all insignificant. Of Nissan, and then this value for Honda. Alright, so these are the AR first row. So this P1 that we have here, after we estimate it, then it will be essentially we have the first row. Minus 0.05, 0.29, so 0.3, so say 29. 73, so that's sort of what we have. And then the last one, which is minus 0.16. Alright, so these are the coefficients that we have. Alright, so then we go to the arch equation. Alright, so the arch equation that we have, so arch of Toyota. Okay. Then we have the coefficients essentially for the arch equation. Well, remember what was the arch equation? The arch equation indeed, so if I basically in the univariate setup, so we had sigma squared equals some omega plus alpha 1 et, I don't remember what I call it, the squared plus beta 1 sigma t minus 1 squared. Right? So that's sort of what we have. So here we have the coefficients for Toyota. There is an arch, there is a gauge, and then there is a constant. There is no more because that's just one parameter, right? So that was this sort of coefficient that we have only one. Right? So these are the arch gauge, basically coefficients for the Toyota, arch coefficients for Toyota. Right, so the arch and gauge, so alpha and beta for the Toyota equation. Then we go to Nissan, then you have the second row first of phi here. Alright. These are the lags that you have, so lag of Toyota and so on and so forth, and they are insignificant. Alright. Then we have the arch for Nissan and the last one which is only. So that's sort of what we have. Good. So these are all of the parameters that are estimated. Then we also have these adjustments, lambda 1 and lambda 2. So there is lambda 1, there is lambda 2. Remember them? Let me show you again. So lambda 1 and lambda 2 vary these angles proposals. So there is a lambda 1 and there is a lambda 2. Right? And these are also estimated. Of course, they have to be estimated, and they are here. So we get them in the very bottom. These are the adjustment parameters. So lambda 1 is 0.3, lambda 2 is 0.87. Right? So which means that the past of the elasticity actually has a strong effect. Right? Which is sort of close to 1, and these are sort of stocks, so that's actually not surprising that this number is very high. Alright? And well, I mean, if you add these two, then you get 0.9 roughly, which is the persistence. Right? So remember that we have alpha 1 plus beta 1 together. In the ARMA 1 indeed setup, they were the persistence that we had in the AR, so ARMA 1. Right? And of course, you get the p values and so on and so forth. So, for example, let's say if I have lambda 1 and lambda 2, here I have that they are statistically different from 0, right? Which means that the correlation is indeed dynamic. Right? So sort of you have a dynamic correlation, conditional correlation. If lambda 1 and lambda 2 are statistically 0, right? So if both of them are 0, if you get here big p values, then it means that you don't have dynamic correlations. So let's go to the model. So if lambda 1 is 0, lambda 2 is 0, then qt will be a function of this only, r, right? So which would mean that qt is not dynamic, it's constant. And if correlation is constant, right, then we will be actually falling back to constant correlation model that we started with. We had CCC and we had DCC. So that's sort of what we have as a difference with it. All right. So, well, as I said, so I don't have very nice data, and then sort of, I mean, to do a very interesting exercise would be, well, I could do this with 3 assets and so on and so forth, but somehow I didn't like it. You can do that. Right? So you have the data, you can take them to Stata and then do enlarge essentially DCC for, say, 2 assets or 3 assets. Say the market, basically excess return and say some asset, right? So NVIDIA, for example. You can do that very easily. And that is what I don't want to actually do, but rather want to sort of discuss what is the usage of this. Right? I mean, leave it as an exercise. Maybe tonight I will Do you know what is hedging? What is it? Hedging? Hedge. That's the verb. And then hedging. Well, that's a strategy, right? Yeah. So for risk management. So this is something you do. And well, hedging works pretty much like, do you have an insurance of your car or something? Right? So that pretty much looks like insurance. So you insure yourself against potential sort of risks. You know? So you get an accident, hopefully you never do, and then your car breaks or so you make something, so the other basically person in front of you just get something off this accident. So then the insurance sort of comes in and then does something. Right? So that's basically, I mean, you're hedging here. For example, let's say you buy an asset. Alright. So you own it, you pay for it. Alright. So I buy, say, one stock of Apple. One. So I buy one. Okay. So then because I own it, and then let's say I think, okay, in 1 year then I can sell it. But then if I buy it, say, at a price of, say, S at period T, so this is what I would buy. So that's called the spot price. It's the current price that you go to the market and then buy. So because it may actually go down, right, so you will lose. If I buy it at 100, and then so after 1 year I say, okay, now I want to sell it, so the price is 90, you sell it in any case, and you lose 10 say dollars. Right? So that's sort of something that we have. So sort of, I mean, to basically reduce this, then generally people say, fine, let's go write a contract. And that's the beginning of the derivatives. You haven't had derivatives. And then let's say we buy a future. Alright. So what is a futures contract?
That has a agreement to deliver some underlying asset in certain time in the future.
That's true. So that has a date. It's attached a time to it. And then there is a specific product with a specific price. Right? So let's say the horizon was 1 year here. Alright. And then you don't know actually what will happen. Maybe the price will go up, maybe down. I mean, potentially if you go down, that's actually the problem, right? Right? So what you do is that, so here you bought it, so you are long. So you are long on this. But now you don't want to buy this now. Right? Well, in some sense, and you buy it to sell it later. Right? So you go short on the future. So here, let's say you go short. And because the price is fixed, right, then you sort of insure yourself against the down movements of the spot price. Right? So that's sort of the idea of the futures. Right? Now the question is, with hedging, is that, so if I own one contract, one asset, let's say, whatever, so one contract I write, and let's say it's a batch of 100 assets of the, well, you started with 1 2 hours. Alright? So then how many for each of those contracts, and how many of those guys actually I have to go short on? Let's call it H. Alright? So it becomes the hedge ratio. Alright? So the hedge ratio is how for each contract that I have, that I go long, how many contracts should I go actually short on the future? So the spot prices and the future prices are known. Right? So these are futures that are actually nice because they are widely available, they're on the market, you can always buy them. So you go short on them. Alright? So they are fixed. Right? And then there are also other ways of securing yourself. So when it comes to hedging, then you don't need to actually focus only on futures, but you can write a specific personalized contract for yourself. Right? So you find an agent, and you say, look, I mean, the futures that are on the market do not match my needs or my risk appetite. I want something else. And then put together some other contract. futures are available, alright? But these personalizer stuff, there are others, so which are CDFs, probably you know them too. Alright? So there are personalized contracts which are not available on the market, but then I go to an agent and I say, hey, I need this and that, and then they put together. So there are actually other ways of putting together sort of this insurance in quotation marks for the future. Now, what is the question is how do I find this age? Alright? How many should I find? Now, how many should I go short on? Let's just stay with the spots and the future prices. These are the tools that they have. Right? Okay. So now, well, do you know what is co-integration?
Yeah.
Okay, very good. So one says, okay, so if you have two items, this is a price, this is integrated order one. This is also a price integrated order one. Because they are somehow related to the same asset, then actually it makes sense to think that these two are related. Alright? But because they are I1, then we don't say that they are correlated, but then we say that they are co-integrated. So there is a co-integration relationship between the spot and the future. Alright? Well, I mean, theoretically. And if I find a linear combination between the two, then the residuals will be in the integrated order zero. Right? So far so good. So now, I mean, if I want to find the age, right? So then what you could do is that let's say we find the returns that you have, well, these two are related, right? So if I take the returns of these, well, no differences or percentage changes, or let's say no differences, well, so these are the returns on the spot, right? So the returns on the spot, and I also have the returns on the futures. I have them both. Alright? So these are the returns. Well, you can think that these two are indeed somehow linearly related. Say alpha plus beta plus some error term dt. Well, it makes sense. If I basically take differences, then the short run dynamics that you have in these prices could also be related. Right? So the Granger or Engler-Granger representation, indeed, when you write the co-integration equation, then decomposes the variation in the short run dynamics into the long run reaction. So you have a reaction function, and then the short run dynamics. So here we are just focusing on the short run dynamics. Now the thing is that no problem. Okay. So, well, so what the thing is that because I went long on this and short on the other one, alright? So then I sort of earned this return. This is what I collect because it's mine. I will sell it. Alright, so I bought it to sell that. And these are the returns that I have. Essentially, well, let's say on a daily basis, these are the returns that I have. And this is what I'm using. Right? Because I went short one, essentially. Right? Well, so what I can actually do is that I will look at, well, I mean, a portfolio, essentially. So well, we can very easily look at the portfolio, but let's say I basically go long on these spots, and then I go beta units short on the futures. So that's sort of what I have as a portfolio. Okay. Well, because I have them both. I go long and short, and I buy one, I sell the other. Right. But let's calculate the variance of this. Alright. So that will be the variance of the risk that I have in my portfolio. Okay. Minimum is all of them that telling you is new. You haven't heard this before. This? Yeah, so that's new, okay. So just didn't want to bring it. Okay. So let's look at the variance here. So then what is going to be the variance of the first plus the variance of the second plus twice the covariance. Right? So that's sort of what we have. So that would be sigma at time t of the spot plus beta squared sigma t squared of the future, right? Minus 2 beta the covariance of the spot returns and the future. So that's sort of what we have here. Good. Can you minimize this in beta? Huh? First look, can you please? That's a very simple exercise. Can you do that? Let's play that. You can look at it in 10 minutes. Alright, so let's write the first one with conditions. Thank you very much. So let me be 2 beta sigma 2 of the futures. Right? 2 over. Alright, so let's write this as sigma t of S and F. The set is equal to. Right? So that's sort of what we want. Let's call this hat. Right? Or that sort of the equation is this, but then the one that solves it is the parameter that we are wanting. Exactly. So theta hat will give me with this divided very nice. That will be sigma t of SF divided by the variance of these both. So well, that was actually, this is not surprising. This is so if we were estimating this from UNS, then you would have gotten the covariance of these two divided by the variance. So that's the OLS beta. Okay? Which is essentially what we gave it a different name. Alright, so remember that we said, okay, let's buy 1 unit of this and then sort of we go long here and we go short on the other by beta units. So we literally start with well, we need some relationship, right? But then the portfolio that we made up is indeed beta. So 1 unit here and beta units long short. Right? That is the reason we have it. So then we have a portfolio. If I minimize this, so I minimize the risk of the portfolio, then I get this shot. Right? Okay. Well, now when we started in Apple, but I don't have, sorry, I don't have the data on the futures. Just have the spot, or the prices, the historical prices. Should have asked my assistant to get them, but then I sort of so that's also indexed by T. Right? So this hedge ratio, well, this is equal to optimal hedge ratio. Why is it optimal? Because it minimizes the risk of the portfolio. So it's a very simple setup. Right? So it's a very, very simplistic setup. So I want to tell you that, let's look at this. So if I have, say, Apple, A, B, A. Alright. And then say I have the spots, and I have the futures. Right. So I have both of them. Then I can, well, let's look at this. This is a covariance which is indeed time varying. Alright. And that's a variance which is time varying. So just talks to me in the sense that we could do and then use a multivariate Large model. So if you use a multivariate Large model, then your hedging ratio, which is this, actually will become time varying. Sort of, well, I mean, one application that you could use for this. But you could have periods, and let's say after 3 months, then you start to really run. So when you write the contract, then you say, okay, so every 3 months or every some period R review, then you start probably what sort of to rechange things, so you give them the new information. Right? What sort of what we need. So if the optimal hedging ratio is very high, right? So well, I mean that's sort of problematic. Well, it depends also on the prices and so on and so forth. But well, I mean, in any case, it doesn't matter. We may not need to discuss the value of this because I don't have the data. But that's one application of this guy. Right? Well, that's sort of, I mean, as an application. Well, another maybe, well, in the book I brought it actually today with me, there are some, well, there are many exercises. So if you look at the papers of these Chris groups, and you find many things with respect to the multivariate Large and how to use it and so on and so forth. It was the book. You would get some copies of relevant chapters of this for the exam. That's the latest version. another application is kappa and beta. Correct. So if this is indeed sort of, so kappa and beta, well, let's say I have here market return, say S&P 500, excess return, and then some asset return, then this kappa and beta would be again the covariance divided by the variance, right? So which we could indeed go on and then use a multivariate Gauge to get it. So that's another application, right? So one can have for this multivariate stuff. And as I said, so maybe with the kappa beta we define tonight an exercise. And I will update it. I'll update this more or less every second day or so, the assignments. So tonight I will add more. Last Friday also added.
Yeah,
some
this
more.
was
You saw them.
but I did not do
You
anything.
didn't do them all. That's good that you did that. Alright, so I want to close this section. If you have questions, let me know.
Sorry, sir.
Yes.
For this to PDF file from Stata, will you upload to the email?
The file?
Yeah, for this one.
You wanted to have the syntax?
Yes.
Sure.
Possible.
Of course. And actually what I did was very simple. I went and then said multivariate or mGauge. I didn't do it. mGauge is that.
Okay. Okay. That's
That's
I think we can do it ourselves.
Maybe I don't upload it, but it's here.
Yeah.
So that's freely available. You can look and so on and so forth. But of course, whenever if you want to apply this and then you have questions, you let me know. I will answer. Actually, the happiest days that I have is the times, moments in the classes that when a student asks me a question. So it makes me happy. If you study and ask me a question, I will be very, very, very thankful for it. All right. Good. So what I want to do next, I want to do Markov switching on this. All right. So I can give you different introductions to this. I can give you historical accounts of what is this, or technical ones, so sort of going into the math, but ignoring what do they do. I could maybe talk to you about maybe you can teach me something about Vietnamese language structure. Okay? So, suddenly you understand what are language models. So what is the basis of language models? Right? For example, I don't know, when you write an email, then you write, I don't know what do you write, thank you, and then what is, so come on, I know it's thank you. And then if you want to say thank you very much, then first you don't say, you say thank you, and then the very much in English comes next. But then in Vietnamese first you say very much, then thank you. Is it not? How do you say
We
thank
still,
you?
for that particular situation, we still follow the same law.
Yeah, so how do you say thank you very much?
Cảm ơn rất nhiều.
Cảm ơn rất nhiều.
So there is come on and then rất
Too
nhiều.
much, yeah. Rất nhiều
So
is
that's
too
sort of something that comes afterwards, right? So that's sort of a structure that you have in your brain. Okay? So, but when you start typing, then somehow if your letter is very polite, then automatically sort of the software suggests retenu, so that you can add it to the comma. So it comes as gray, and then you press on it, and then you add it to the sentence. How does the software understand?
I think they have a kind of like a library or like a store memory somewhere on those most frequently used phrase.
That's true. Yeah, very good. And we want to understand it now. Okay? So now we want to understand essentially how things work. And can I ask one of you to write a sentence to get ready on the board?
I
Can you
biết
do that?
cảm ơn rất nhiều cái này.
Some sentence, I don't know. So that, whatever. But something that is mean. Oh, thank you very much. So you have also in Vietnamese vowels, like A, but then there are a lot of stuff on top. Alright, so,
Yes.
yeah, so then, but that still is a vowel, right? For example, let's say when I see, here, for example, now, I don't know if I pronounce it correctly, which would mean max. And then there is something which becomes the south, Vietnam, which is longer, and that is N-A like that.
Still, it's still spelled exactly the same thing.
Oh, yeah. That is the south, but you read it different.
No, we read
No,
it the
no,
same.
it's the
You read the same?
But it's just like in different context, then you will be able to tell what is the meaning.
But it's possible to have this with a different,
Yes.
some, for example, what? Near. Near.
No, it's like on the letter A, if you put like a hat and then an exclamation, then it's mean mushroom.
Really? Alright, so then you can go on and on. These are still a vowel. They are vowels. So that's not actually a new word, that's a vowel. And this is a consonant. So when N is a consonant, M is a vowel, right? Okay. Come on, right? Can you continue a little more with your sentence? There's a dog. That's right. Let's write one more sentence. And we do this in the way, and soon when you apply this stuff that I will tell you in econometrics. We will estimate the capital model. It's these models that you have, when they suggest something to do, they are really this statistical, they're econometrics. I agree, just for the moment. Thank you very much. So, can I have my, so the pen and take, that's very nice. So here what do we have? We have C, and that's a consonant. Alright, so, let me just rewrite this. So we have a consonant, then we have a vowel, and then we have a consonant. Right? That's sort of what we have. That is CAM, and that is CBC. Right? And what about on? That is a vowel. This, well, this CAM, and then we have a, a consonant, and sorry, a vowel, and then there is a consonant. Right? So then I can continue on and on. So now let's say, so here, then I have a consonant, then there is a vowel, and then there is a consonant. Then there is another consonant, there is a consonant, there is a vowel, vowel, vowel. And then, let me forget about the exclamation mark if you don't mind. And then we have consonant, vowel, consonant, consonant, vowel. Why is a consonant? Consonant, consonant, vowel, vowel. Consonant, vowel, vowel. So this is one, that, you, right? And so on and so forth. Right? So we have got this sentence, right? Can you write a Python program? Forgetting about the accents, these ones that you have on top, alright? Removing these guys, this is casual with the text together, and then count how many times a consonant is followed by a vowel. Here, we want to count in this sentence how many times the consonant is followed by a vowel. So now we have a consonant, the next is a vowel. Alright, so for the vowel, I mean that means, let's say, let me go here, there is a count. consonant, a vowel, so one. Well, vowel, next is a consonant, this is not vowel. And then here I have again a consonant and a vowel. Good, let's go to number 4. That's a vowel, then a consonant. I'm not interested. And then a consonant becomes a consonant. So I'm actually looking for all the C's. Right, so C. And so on and so forth. Well, I mean, I just don't program it, you tell me. So you should restrict sort of split this, do whatever, attach all of these sentences, the words together, right? So remove the spaces, and then count how many CVs you have. And you tell me the number. So these are vowels that come after a consonant. How many? I couldn't type this in Vietnamese. That's why I'm telling you.
code, then you can write this and then.
Hôm nay 6.
So here we have 4, there we have 6, and there. Eight. Alright, so that is what we have.
Yeah,
Very
8.
nice, there are 18. Okay. So can you now do the BC? Now CB, let's say I start in a vowel. Alright, so this is C goes to become B. A consonant, you start with a consonant and go to a vowel. Right? So here we have C, and then becomes a B. Now I want to do it differently. Well, you do it differently. And you start with vowel and then become a consonant. So it goes 4, 6, 8. So it means that here we have in this we have 18 vowels. In here we have 18 vowels that their previous letter is a consonant. Consonant. So now let's do it the other way around. That will be vowel to consonant. So that is vowel to consonant. That is AC. Right? Vowel to consonant 2. Vowel to consonant 3. That's it. There's no more. Right? So that is what we have. And the next. So we're 1, 2, 3, 5, and the last. Eight. Very nice. So that's sort of what we have. So let's add them. Right? So that's sort of what we have. Let's add them. So here we have 18. And then that is 16. Thank you very much. All right. So there are also other situations, right? The other situation is that you are at the vowel and you stay in the vowel. Right? So that's another one. And then you are at the consonant and stay at the consonant. And so what is both? Right? You can also go count. Do some numbers. But let's start with counting. But I just wanted that you do the counting and then start programming such that later we can do further stuff. But maybe let's visualize this. Right? So here we have consonants and then we have vowels. Alright? Consonants become vowels. So it means that when you are a consonant, then you may become a vowel in the next letter. Sometimes when you wrote a Lynn, you were Lynn? Lynn actually wrote the sentence for us. Sometimes she chose a vowel, and then because of the structure of the language, then afterwards wrote the consonant. Sometimes you also wrote the consonant, and then the next letter that you wrote, yours was also a consonant. And then sometimes vowel was, you had a vowel, and then afterwards you had a vowel. That's a network. Now, so here, how many letters do we have in total? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Can somebody tell me the number of, or you have the programs, right? So how many letters do we have? vowels are followed by a vowel.
Vowel stay constant is like 63 minus 16 over 63.
But actually very low, very big.
Yeah.
So sort of, maybe there is some problems here with the counting, but maybe, right? So well, a vowel either stays a vowel or becomes a consonant. So it can't do anything else. A vowel is followed by one other letter. And then we can count. So your suggestion is that 63 minus 16, so that is 53, 47. Now let's see the leading. That's sort of, this is the case, we have to check it. And then a consonant becomes a vowel or stays a consonant. So that is.
Oh, no, I think I get it wrong. No, I get it wrong.
That sort of should be a little bit different.
Yes, we need to count 40 on the sides. So the 47 is the total that either the C can stay the same and the B can stay the same as well. Right?
Right, I mean, these are actually, so this 63 includes the vowels and also the consonants.
Yes, so the 47 is like either the C stay the same or the B stay the same.
Exactly. So that's actually a different fraction. But let's keep it as is. Alright. So we just keep it as is. Alright. You're not wrong. Right? You're correct, but these are two different probabilities. I will tell you in a minute what these guys are. Alright. So that's sort of a little bit different, as I'm just basically saying. And then there's another number. Let's say, well, let me just put it in a box. Remember, these are put in boxes, such that we are a little bit careful with it. Right? Because we have to, well, these are actually, this is not the probability that, because you have to focus on vowels. Alright, so this minus some number. So you have to calculate. Alright. That's, I mean, this fraction is also a little problematic, alright? Because, well, I mean, if I want to be, so, wait a moment, so if I am a vowel, then I become a consonant, but conditional on the fact that I was a vowel, alright? So that also is a little problematic, alright? I have to subtract something from it too, alright? And then, and so on and so forth. Right? So basically, well, these numbers, we have to be a little bit careful with when we count them. And then here are the consonants. So remember this question marks that I'm putting here. I want you to, it was very nice that you did this sort of calculations, such that you remember or sort of remind yourself of the fact that when you calculate this thing, you should remember that you were a vowel, not that you were a vowel or a consonant. All right? So I am a vowel and then become a vowel. Right? So it means that this sort of the denominator that I have here should not be 63 because it includes all of them. Right? So you understand. And then there is some other basically quantity that we have here. You can go calculate them carefully. Right? But let's actually, for the moment, make this a little bit simpler. Right? In the sense that I will just wipe them. We come back to the numbers again. Right? And then we call this not C and B, rather 0 and 1. Right? So I'm in the state 0 or I'm in the state 1. That was a consonant, this was a vowel. Right? Now, when I will attach to this basically edges, this is a graph, and this is a loop. These are loops, so these are edges that connect two nodes. This is one node, this is another node. Or you can think of them as a space. So now let's actually accept some notation. Say I have P00. P00 is the probability, that now becoming more specific, the probability that I am in 0 and go to 0. So I'm a consonant and then fractions, as you see. So fractions, you can think of them as, well, if this text was very big, and we were counting these guys properly, then we would have had the probability that when you are in a consonant, then you go to a consonant, right? I stay a consonant. So if I am in the state 0, then I stay at the state 0. So P0, 0, and then P1, 1, P1, 0, and P1. Yeah? So these are basically the probabilities that move me from one state to the other. Indeed, the P0, 0 right, is the probability that, well, let's now use a variable which let's call it a state T. And T is indeed the location that you are. So you start from somewhere and then you go on. Right? So the probability that the state T is 0 if a state T minus 1 was 0. Or in general, the probability that I go from a state I to J is the probability that I was in a state I, right, and I went to, that I was in a state I in the previous location, time, and then I went from I to J. I was in I and I went to J. Right. Well, from 0 to 1 to 2. So that's sort of the general, basically, situation. So ST is either 0 or 1. So here we have ST. Is 0, 1. At every point of time, you are either 0 or 10. Well, that's sort of what we, so what I have, and I wanted, what? I mean, if you see, so going from vowel to a consonant, it has a probability, which is the underlying probability. So if I could actually read all of the texts, which are in Vietnamese, I can't, all right? But a very big one, a text, I could basically pass it to some text analyzer and then check. So what is this probability? That when I was a C, then where did I go, essentially? Right. So that's sort of what we can do. Right. So, well, I mean, these are conditional probabilities. But what I want to do now, with this now, I want to take you a little bit ahead. Let's say I have a time index. Well, time is the position that you will write in your sentence. Right? So 0 and so on. Let's say I am at, oh, well, that's sort of the time index. Let's say at time t, I am in a consonant. Or well, let's say t minus 1, so that's a little bit better. So let's say t minus 1, I am at constant. Then what is the probability that I stay at the constant? That is sort of P0, 0. Right? So that if I am at 0 consonant, the probability that I go to a consonant is P0, 0. Right? But let's say I do a little bit more. Right? So what this model that I had here was that it was always looking at now and then telling me with which probability I will have a vowel or a consonant in the language, or so in this text. Alright? And what I want to do a little bit more is that, well, let's say I am at 0, alright, 2 periods back, minus 2. Alright? So I want to know what is the probability that ST is 0 if in 2 periods back, well, in last period I was at 0, and 2 periods back I was at 0 too. So not only I know the previous letter, but I also know the one which was before. Consonant, consonant, consonant. Right, so I want to calculate this. Okay. So we start at this, and well, sort of from here, then I go there, and then from there I go there. Alright? I want you to show that this is equal to
this event implemented?
That's what you should show. Yeah, but you're right. You're very right. Okay. Well, I mean, independence maybe, well, it's a little bit easy there, sort of, a little bit hard maybe to talk about in this framework. Okay, but let's not show it. Let's not show it for the moment. Let's say it holds. Okay. Let's say it holds. Then if this holds, then it tells me that I don't care about the distant past. Alright? This is what it says. I just care about yesterday. If I know yesterday you were in a vowel or a consonant, then I know with which probability I will be in a consonant. If I know this, then let's say that I will have the future. I will see the values. Alright? Just yesterday is enough. Alright? Well, well, you should know the law of conditional iterative expectations. Probably you have seen it sometime. Alright? Well, so what information is here? It is that we know that we are a consonant. Alright? But we become a consonant depending on something that happened before. Alright? So this ST minus 2 may have been 0, may have been 1, and then somehow we got there. Alright? Well, so to speak, this became 0 because of somehow we started from somewhere. Either we were in a vowel or we were in a consonant, and then somehow they came together, and then this was realized. And then we were and so to speak, this being 0, it includes some information about the past. Alright? This means that this becoming consonant includes information on the past. So this is included in here. So the information set here is larger. We know more how this is generated compared to this. That's like sigma algebra, right? So that you have, so as time passes, you have more and more information. And so to speak, conditioning, when we condition on that, then you already condition on this too. There is already, it's already conditioned on. And so to speak, it doesn't matter. So that's sort of the logic. Right? So it's not independence, right? So it is not about independence, but it is rather about the information set. And the information that we have here, we have in ST minus 2, is already included here. Right? It is already there. We know what happened before, or it has been there. So that's sort of, it is conditioned on the past. Right? So sort of the past information matters. This is something which we call it the Markov property. So Markov property means that only the most recent past matters, not the previous. That's sort of what we have.
Sorry, this one and the martingale is the past information, all the past information.
Well, that's the same as the martingale property. Alright? The martingale property is about the expected values. This is about probabilities. It's slightly different. Right? You remember that?
Yeah, I remember the martingale.
Exactly. So martingales, generally we talk about them in terms of expected value, not probabilities. Okay? But this is actually what Markov brought up some 100 years ago. Yeah, so well, sort of after the Russian Revolution, so around that time. So that is why we call it Markov property. Essentially, if you read, I speak Russian, and I can read Russian, so I read his stuff, right? I read essentially what he wrote. It was exactly the same thing with the vowels and consonants, but in Russian, right? That he did. So I just now did it with you after some time. That was what he did back then. So he did a lot more calculations, he did the proof, and so on and so forth. I know. So it's actually very interesting that sort of you realize the connection, sort of the similarity with the martingales. The martingales are defined as with respect to the expected values. That's different, slightly different compared to the probability. So here we have the probability. Well, so far so good. So you've seen, are you happy, Min? Or are you thinking?
Yeah, I think
we can talk and discuss because this understanding of this is very important. Alright. Okay, so let's say we have this. Okay. So let's maybe make this a little bit more fun. Alright. Well, let's collect these probabilities in one matrix. Alright, so here we have P0, 0, and then from 0 you go to 1. P1, P10, and then P1. Alright, so that's sort of what we have. So this is a matrix which we call it the transition probability matrix, because it helps us go from one state to the other. Alright. So, well, let's say these are the transition numbers, right? Which are conditional. Alright, so that's sort of what we have here.
Sorry, just curious, let's say we have more than one state, right? Then the dimension of the matrix will be expanded.
Yes.
And can this be thing like, can we find like the kind of like the shortest route to reach a certain node?
Oh yes, okay, so let's make it a little bit maybe bigger, okay? So it's sort of what we can do, right? So that was about letters. What was the code? I will answer you with an extensive explanation. Right? Well, this was actually simple. Vowels and consonants. Right? So you want more. Okay. So now you teach me a little bit more about your language. Okay. What is the structure of a typical sentence? So you say a man came, and he had a big bread in his hand. Yeah, so something like this. Okay. So, or 2 books were more expensive than 3 books. Yeah, because the first 2 books were different. The Barney series, the others were not. Right. So something like this. So, well, I mean, we need say I have 2 books, but it seems like that I have a determiner. Right, so let's call it debt. Right. Let's just write the structure of a sentence. So generally we have debt. So I'm not actually on letters, but I'm on words. Right. I want to go and then become a little bit more complicated and have a language model, essentially. So these are the basics of the language model. So you have a determiner. Then you may have a noun. Alright. You may have adjectives, you may have adverbs, right? You may have verbs. What else do you have? Prepositions. Do you have? Yeah, sure. All of the language have. And then sort of you may have also an end of the sentence. Well, let's keep it easy. So 1, 2, 3, 4, 5, 6. Well, let's also add prepositions. Alright, so that's sort of something like so. These are, well, 7 elements of the sentence. Now let's say we analyze the texts that you have in Vietnamese. Right? Now, so, well, the sentence will start with something. Right? So let's say it starts with the term 2 books, or 2 number, or a man, a, and then so on. So, well, then oftentimes, well, let's say oftentimes you start with the determiner, but then what is the probability that if you are at a determiner, then you go to a noun? Alright, so after the determiner, sort of man, book, 2 books. Right, so after the determiner, then you may actually have a noun, right? So you may change the state, right? So let's say this is the state 0, then I can have the state 1, right? The state 2, 3, 4, say 5, Can you tell me something about this? So, for example, let's say, what is this? Noun. That's a noun. So a noun, and then this one is a noun. Okay. Yeah? It is an adjective. And this also adjective.
No, it's like that, but
With the two together are an adverb. So here we have a noun, and then we have an adverb. This is a verb. Okay. This what? Is a number. So I one. This is one, right? So this is one.
Chút
That's
chút
apple.
là tính từ nha.
Oh yes, I think I've seen this.
Biết nữa, biết nữa.
And so that's over. So if you look at this and somehow has some of those, and then not all of them. So that's sort of very, is it right? It is a verb. Oh, okay. But this sentence has a verb. Do not a verb. How can you form a sentence without a verb?
no, I think
The verb is two-way because the sentence describe the sky, the gray sky with no sunlight.
Oh, that's a very poetic. That's a poem. Yeah, so it looks like a little bit complicated, right? So maybe I need more sentences so that I could understand the structure. But let's just stay with this, right? So with the simpler stuff. And well, I mean, somehow there are states. So you have some verb and then some determiner, some number, there is an apple, and somehow there are names and nouns, and then they come one after the other. Right? Well, so to speak, well, if I have a determiner, then I may go to a noun, I may go to a verb with some probabilities, right? So, and so on and so forth, right? Let me go program this so that you see, and then generate some sentences randomly. Okay? So that would be more fun, I suppose. I think if you know, so that's sort of what understanding. In the second section, once you understand what is going on, then I will do the econometrics. Once you understand the methods, then it will be good. And then we can take them and then do the maths, which is not a big deal at all. Okay? Let me start by doing some little programming here. let's just say the states are, well, I mean, let's say we have a determiner, there may be that there is a noun, there may be a verb, right? There may be an adjective, there may be an adverb, there may be a preposition, right? And then there may be an end of the sentence. Right? So these are the states of this general sentence as you have it here. Okay? So and how many states we have? So 1, 2, 3, 4, 5, 6, 7. Right? So that's sort of what we have. Now let me define a matrix P. Alright. Of an array form. Okay. And the array looks like so. So these are the states. So if I have a determiner, alright, so you don't say A happened. Well, a determiner is never followed by a determiner. So you don't say two books. You don't say the tree. Okay? Once you have that, then you go out. Right? So once I have, so when the first state is sort of, you don't actually stay in the status of being a determiner. So then we write the probabilities like so. Right? So here, from that to go stay in a that, there is no chance. So that's 0 probability. And if I have a that, then I go out. Or sort of some articles there. Alright? But let's say if you have, so I'm just simplifying. So if you have a determiner, then with probability 1, then you use next a noun. I'm simplifying. Alright? You can say no, it is not correct. Is it? So can you think of something where the determiner in Vietnamese is not followed by noun? Probably. Probably you can think of. But I'm simplifying. I'm saying, right, once I use a determiner, then for sure I use a noun. And then the rest are 0. So I never use a verb after the determiner. I never use an adjective. I never use an adverb. I never use a preposition. And I never end. So I just talk a little bit further after I use the determiner. Right? So you say the book and then maybe something. Right? So that's sort of what we have. So here we have the determiner. So that's sort of, so the determiner is always followed by a noun. Alright, so that's always means very probability 1. Okay? So let's go next. So now I am about a noun. I'm talking about a noun. So if I am a noun, then let's say I don't go to use a determiner afterwards. Alright? So from a noun, I don't go to a determiner. Or let's say I don't use 2 nouns consecutively. Alright, so I don't say, what is this? So you can say big book. You don't say book tree. Alright, so you don't naturally use 2 nouns next to each other. You can correct them. Alright, so that's sort of for your own case. But then I may actually, after a noun with a probability of 70%, go use a verb. Right? The book is. Alright, so that's sort of something like that. But actually, before that, I may use an adjective, or maybe an adverb, alright, or maybe a preposition. But I never end the sentence. Yeah. So is it clear what I'm doing? So there are conditional probabilities. So here I am a noun, and then the go becomes something. So with these probabilities, so 70% a verb, 10%, 10%, 10% adjective, either a preposition, and then 0% an end. Alright, so that's sort of what we have. Alright. Let's continue with a verb. So if I'm a verb, I never go to a determiner, but I may go to a noun. I ate consecutively, so that's 0. And then let's say 0.2, 0.4, 0.1, and 0.1. So, well, essentially I may end the sentence here, so just put some numbers. And you understand the meaning of all of those. Alright, so these are the probabilities that I am a verb, and then what do I become? So I am a dragon and I become a prince. Yeah, something like this. And then let's do, so that was what? So that was for the noun. Okay. That is for the verb. Now I go to the next one. Let's go with the adjective. I don't go to the determiner. I don't go to a noun. Or I could actually go to a noun. Big book. I don't know. Do you actually say big book in Vietnamese? So first the adjective, then the name. You can't. Not so much. So that's the opposite. Okay. So that's actually ours. That's nice. So then let's choose this 0. So if I have an adjective, then I don't use a noun afterwards. Alright? Yeah. So that's 0. We never do that. Okay. And well, let's say if I have an adjective, and then could I use a verb? Maybe not. I don't know. You can tell me. So 0, 0, and then do I use another adjective? Maybe, maybe not. I just set it to 0. But maybe I use an adverb. Alright. With a probability of 0.4. Alright, say. And then I may use a preposition, and then afterwards I may end the sentence with a probability of, say, 0.4. I just don't use adjective. So do I use, so how many there are? So here we have 1, 2, 3, 4, 5, 6, 7, 8. So, comma. Let's do another one, so that's the adverb. So just put some numbers, and then you understand the meaning. So 0, well, let's say 0.4, after an adverb probability 4, for 40% I may use a verb. I may use an adjective, or I may use an adverb, another one. I may use a preposition, and I may end the sentence. So 1, 2, 3, 4, 5, 6, 7. Alright, so that is for the adverbs. Let me ask the question, and now this is so 0.5. So I may actually, after a proposition, go to again a determiner. 0.5. Go to